Hello guys, today let's derive time-dependent Schrodinger wave equation on our channel. Let's learn from each other. So now consider a particle of mass m moving in positive x direction with potential energy Vx, momentum p sub x and total energy Be. The matter wave associated with this particle can be expressed by one-dimensional wave function psi. We have, the psi equals to a e to the power minus I e t, where t is a time, minus p sub x into x divided by h cut. So when this minus multiply inside the bracket, we get this equation 1. Now partially differentiating the equation 1 with respect to t, we get this. If you know the differentiation, you can easily understand this portion. And d psi by dt, we get minus I e by h cut psi. You see this whole portion is psi, so we written here psi. E psi equals to d psi by dt dot h cut by dot minus 1 by I, where minus 1 by I is equals to minus I, so E psi becomes positive, so we can write this as a equation 2. Now again we have to partially differentiate equation 1 with respect to x. Let's see what we get. Before we differentiated the equation 1 with respect to t, now we have to differentiate it with respect to x. So similarly we get this result, and this is same as psi, so we written it in place with psi. Now again we have to double differentiate it with respect to x. Now double differentiating, we get since these are the constants, it remain the same. This will differentiate as d psi by dt, and we know that d psi by dt is equals to I p sub x psi by h cut. So this will give us this, and then the p x square sub p square sub x psi equals to this. We have just manipulated this into simple forms to get p square, that is our momentum square, psi equals to minus this and h cut. We can write this as a equation 3. And this I, the square of I is minus 1, so this portion become minus 1. So when we multiply the both side with minus 1, we get this portion as minus. So I have written it directly. You hope you will understand it. We can write this as a equation 3. Now from classical mechanics says that total energy of a particle is equals to kinetic energy plus potential energy. So kinetic energy is momentum square by 2m plus potential energy. Multiplying the both side by psi, we get this. Now before we have evaluate the value of momentum square psi and E psi, that is total energy psi, putting this in equation 4, we get psi by dt h cut I equals to minus double differentiate of psi with respect to x and h cut square by 2m plus v into potential energy. This equation is the actual Schrodinger time-dependent wave equation in 1D. If you want it is in 3D, we can just replace this with the del square, and del square, because it is like this in all dimension, we can get it in all dimensions. So this is the derivation of Schrodinger time dependent equation. Hope you like it.